Alright, this is the last question in the worksheet, question 17. Try to do this question at the end when you have had some revision of the material and try to do it as a test. I think you will learn a lot more from it if you do it that way. So you need to complete the reactions. You either use the type of formula indicated in the question, you don't need to include states, and you assume that all combustions are complete. Now this is a combustion equation that's already written out, so all you need to do here is just to balance. And I'm just going to remind people that the way that I tend to balance is I start with carbon and then hydrogen and then oxygen. This is the way that I balance combustion equations. So you have 4 carbon on the left, so put a 4 here. It's a good habit to fill in the blank when there is a blank to fill, even if the answer is 1. You don't need to do it otherwise, but because the blank is here, it's just you know, a good manner to do that. All right, hydrogen. I have 10 on the left, so I need 5 here, so I have a total of 10. So just think about how many oxygen you have. You have 8 and then 5, so that's a total of 13. So I need 13 over 2 here. So that's part A. Part B, similar, you have another combustion. I'm going to follow the same procedure. So I'm going to start with carbon and then I will balance hydrogen and then I will balance oxygen. So you have 2 carbon on the left. I'm going to make a decision that I'm going to have 1 here. So I need 2 here. Then you have 6 hydrogen here, therefore you need a 3. So that's 4 oxygen. Let's write down. And then that's 3. So that's a total of 7. When you go to this side to balance, remember that there's already 1 oxygen in here. So that only need to give 6, which means you only need to put a 3 there. So people tend to forget this oxygen. It's very important not to, because it's going to stop your equation otherwise. We have another equation here that you need to complete. You need to recognize what type of reaction this is. And one way to do it is to know what this is. This is an alkane. It's a very good idea to remember the general formula. Also, because alkane is the only one that has 1 carbon. Alkenes start with ethene, which has 2 carbon. Anyway, this is an alkane reacting with that. This is a substitution reaction. When you replace a hydrogen for chlorine. So if this is one of the product, the other product must be CH3Cl. I mean, even if you don't know what this reaction is, mass is conserved in a chemical equation. It needs to be balanced. So if there's already 1 H here and 1 Cl, then this molecule must only have 3 H and 1 Cl. So if you use logic, you can also do this question. State is not required, so I'm not going to write it here. All right, this is a little bit, well, actually, no, it's the same. This is an alkene. So if you don't know, an alkene will undergo addition reaction instead of substitution. So if I draw it out, this molecule looks like this. And if you react it, okay, that was not supposed to happen. If you react it with chlorine, you're gonna have only 1 product, and that's when the double bond is broken for the chlorine to go in. So the hydrogen stay where it originally is. I feel like my writing part is running out of something, battery or something. Okay. Or you can just use common sense, and because there's only 1 product, it needs to contain everything in the reactants. And you know, common sense is sometimes not common, I think, especially in chemistry, because people don't actually have the common sense of chemistry yet. Anyway, there you go. All right, what does it look like? Part E, sorry. This is an ester, which means that when you write the 2 reactants, one of them has to be an alcohol and the other has to be carboxylic acid. Always break the ester in somewhere here. So the side that has a C double bond O, this is the acid side. and the side that has the single bond oxygen is the alcohol side. When you write the two reactants, you're going to add OH to the acid, and you're going to add the hydrogen to the alcohol. Okay, so I have CH3 COOH, that's my acid. It's okay to start like that, that's okay. This is fine, which is a little bit faster actually. There you go, and that's your alcohol. Or if you want it to look, you know, not twisted, you can write this, it's okay, as long as you don't have the H here when you write in this way, because that would be wrong. Okay, I just go back. There you go. F. Right, so this question asks for name. This is actually the easiest of all because you use the type of formula indicated in the question. So if the question has names, I'm going to write names, which is so easy. If I have methanol reacting with propanoic acid, then the name of the product is methylpropanoate. And the other product will be water. There you go, done. G, what is this? Okay, I have an alkene. That's not actually legible. Alkene, and you have water. So, well, steam really. This is going to be an addition reaction because that's the only type of reaction beside combustion that an alkene can do. You want to concentrate around the double bond, and everything else will remain the same now because I don't want to do the whole up down. I'm just going to draw it out. Okay. All right. Question has structural formulas, so answer must have structural formula. That is a terrible way to draw the covalent bond, but I think I'm going to leave with that. All right, this is where the double bond originally is. So I'm going to break it. I actually have heaps of room on this side. I don't know why I start randomly like that. Okay, never mind. That's fine. One of the hydrogen is going to go here, and the OH is going to go here. So you have an alcohol. Or, and you shouldn't draw both, you can have the OH on this side, which means that this is the other possible product. Okay, let's just redraw. So we start with everything that the molecule originally has, which is a hydrogen down here, a hydrogen up here. You can change the position of the hydrogen, that's okay. It's not a big deal. Okay, you can have the OH on this side. It is a different molecule. This one is a pen-3O, and this is a pen-2O. So it is slightly different, but because there is no indication in the question as in what type of alcohol is going to be formed, you haven't learned that anyway. So either of these is okay. All right, next question. Once again, this is an alkene. This is a structural formula, so I need to show structural formula for the product, and the reaction is still addition. Okay. Whoa. Sorry. So break the double bond. Okay, first carbon, second carbon. Now the first carbon is just the CH3. And then we have this, which has a hydrogen, followed by another carbon that has a CH3, followed by another carbon that has a CH3. Alright, I'm just going to put a chlorine here and a chlorine here. Because they both chlorine, it's really only one way that this can go. That's it. Okay, I think that's our polymer, isn't it? Alright. Now when you need to draw the monomers from a provided section of a polymer, you need to, the first question you need to ask is what type of polymer is this? Although this question doesn't really make a lot of sense in year 11 because you only learn one type of polymer, which is addition. But when you get to year 12, there's another type of polymer, so you have to ask an extra question. Now, if it is an addition polymer, it means that the monomer must contain carbon-carbon double bond. Okay, so if you draw the monomers and they don't have carbon-carbon double bond, you've done something wrong. The other thing is, if you have addition polymer, sorry, you want to break the polymer every 2 carbon, because that's potentially where the double bond is going to be added back. And you want to see how many types of monomers you can have. But by the look of this, you only have one type, so you have a CH3, CH, CH2, and it does repeat, even though the location of the CH3 changes. The question doesn't, this is not a structural formula, this is, I don't even know what this is. So I don't think it matters too much what form of the, what type of formula we use for the monomer, as long as it's correct. I would accept all of them. Okay, it's very, very simple. This is the only type of monomer present. All you need to do is to add the double bond back to the backbone. Probably put an N here, and then you're done. Easy. Okay, this is another one. Now, this is an ester, and I know that this is an ester because of that. This is an ester functional group. So when you write the reactants, you need to break it here. This side, which has a C double bond O, that's your acid. And the acid, you're going to add an OH back to it. And this side is your alcohol. And you're going to add a hydrogen back to it. I'm just going to finish the equation before I forget, using structural formula, just like in the question, and that's water. Okay, so the acid, let's see, 1, 2, 3, 4. There is a double bond O at the end, and then we're going to finish with that. This, the one next to this, has a CH3. This is messy. Why did I write this question? I want to live with that. No, I'm not going to live with that. Okay, there's your acid. The alcohols on the other side. I hope you have, I will give you more room than this, obviously, but because of limited space, I'm going to write this up down here. So CH3, and then you have a carbon here, and a carbon here, and then you have this O, followed by this H. Just to remind people, this part comes from here. So that's your alcohol part. You don't really need to show this in your working out, but anyway. We're not done. We're almost done, I think. Alright, this is good. Probably the most challenging, which is the skeletal structure. This is an acid. This is acid. And this is an alcohol. So the structure of the product, this is, you are forming an ester basically. Now, this is going to be a little bit of a pain to draw with this pen, but I see how I go. Okay, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. And then double bond O. And then this O is this O, 1, 2, 3. 1, 2, 3. There's a branch here. This is probably a good way to draw the ester using skeletal structures. You want to make sure the number of carbon matches, because this is very hard, and people tend to think this is a carbon, but it's not. 1, 2, 3, 4, 5. You're supposed to have 5 carbons on this side, including that branch right here. 1, 2, 3, 4, 5. So that's good. And then this side, 1, 2, 3. 1, 2, 3. So I think I'm good. You don't really have skeletal structure for water, so I'm just gonna draw it like that. Is that it? That's it. That's the end.